Recording in progress.
Section 8.4, skills practice 8.4, gas laws. Our main equation that we're working with is P1 V1 over T1 equals P2 V2 over T2. Remember, if you see units in atmospheres, pascals, or kilopascals, those are units for pressure. If you see units of cubic centimeters, cubic meters, or liters, those are units for volume. Let's take a look at the example. A kit used to fix flat tires consists of an aerosol can containing compressed air and a patch to seal the hole in the tire. Suppose 10 liters of air at an atmosphere of 101.3 kilopascals is compressed into a 1 liter aerosol can. What is the pressure of the compressed air if the can temperature remains constant? We are given 10 liters. Liters is volumes. That's the first volume listed. We'll call that V1. Kilopascals measures pressure. That's the first pressure listed. We'll call this P1. Into a 1 liter container, that's the second volume listed. We'll call this P2. And we're looking for the next pressure, the second pressure at a smaller volume. So P2 is the question. So we're looking for P2. You can see that P1, V1, and V2 have all been given here. The relationship we initially always write down is P1, V1 over T1 equals P2, V2 over T2. Okay, now, as we said at the top of the page, any constant variables get canceled. Okay, that's kind of important because when you do your reading and your annotating, here we are told the temperature remains constant. So we get to cancel T1 and T2. The reason we get to cancel them is because T1 equals T2. They're the same temperature. And if they're the same, they're going to cancel on both sides of the equation. So the equation gets reduced to P1, V1, equals P2, V2. And recall, we are solving for P2. And we do that by isolating P2 and getting rid of V2. We get rid of V2 by dividing it away. So P2 would be P1, V1 over V2. And we're plugging into that. So P1 would be the 101.3 kilopascals times volume 1, which is 10 liters, divided by volume 2, which is 1 liter. We should be able to see that the unit of liters cancel and that our answer is going to be left with the unit of kilopascals. Putting that into our calculator, we're just multiplying 101.3 times 10 and we get 1,013 kilopascals. Number 1, the air inside a tire pump occupies a volume of 130 cubic centimeters. We'll call this V1. At a pressure of 1 atmosphere, that would be P1. The volume decreases to 40 cubic centimeters, that would be P2, and we're looking for the pressure P2 if the temperature does not change. So we're looking for P2. We are given P1 of 1 atmosphere. We're given V1 130 cubic centimeters, and we're given V2, which is 40 cubic centimeters. Our main equation is P1 V1 over T1 equals P2 V2 over T2. Again, we get to cancel temperature because temperature remains constant. And rewriting the equation, we are working with P1 V1 equals P2 times V2. Again, you're solving for pressure 2, so again, you're going to divide away volume 2. Cancels. Substitute your numbers. P2 is going to be equal to P1, which was 1 atmosphere, times V1, which is 130 cubic centimeters, over 40 cubic centimeters. Cancels, and we're going to divide 130 and 40, and we get a pressure of 3.25 atmospheres. So we're dividing by a lower volume, thus the pressure. Number 2. A gas occupies a volume of 20 cubic meters at 9,000 pascals. If the pressure is lowered to 5,000 pascals, what volume will the gas occupy if the temperature does not change? We are given volume 1. Pascals measures pressure, so that's pressure 1. The pressure is lowered to 5,000 pascals, that would be pressure 2. And you are looking for volume 2. V2 is the question. P1, we are given V1, and we are given P2. P1 is 9,000 pascals. PA is the abbreviation for pascals. 20 cubic meters, which would be abbreviated with meters cubed. And then the pressure reduces to 5,000 pascals. Write down our equation. The temperature does not change, so we get to cancel temperature on both sides. Again, P1 times V1 equals P2 times V2. You're solving for V2 this time, which means you're going to divide away the P2. And V2 is going to be equal to P1, which is 9,000 pascals, times 20 cubic meters, divided by 5,000 pascals. Pascals cancels, leaving with a unit of cubic meters. And volume 2 equals 36 cubic meters. Number 3. You pump 25 liters of air, that would be volume 1, at atmospheric pressure 101.3 kilopascals, that would be pressure 1, into a soccer ball that has known volume of 4.5 liters, that would be volume 2. What is the pressure? P2. P2 is our unknown, if the temperature does not change. So we are given P1, we are given V1, and we are given V2. P1 is the 101.3 kilopascals. B1 is the 25 liters. B2 is the 4.5. Let's write the equation down. Again, the temperature does not change, so the temperature gets canceled from the equation. P1 times V1 equals P2 times V2. We're solving for P2, so divide away the V2. P2, let me see, we're going to go P1 times V1, so 101.3 kilopascals times V1, which is 25 liters, all divided by V2, which is 4.5. Cancels. And we get roughly 563 kilopascals. Number 4, at 400 Kelvin, that would be temperature 1. The volume of gas has a pressure of 0.40 atmospheres. That would be pressure. What is the pressure? That would be P2. P2 is the question mark. At 273 Kelvin. So that would be temperature 2 if the volume does not change. So here we go. We have pressure 1, temperature 1, and temperature 2. Pressure 1 is 0.40 atmospheres. Temperature 1 is 400 Kelvin. Temperature 2 is 273 Kelvin. Write down our combined gas law equation. This time, it's the volume that does not change. So let's cancel the volume. And the equation we're working with is P1 over T1 equals P2 over T2. Now, in order to change this from a fraction proportional looking equation, we're going to cross multiply. P1 times T2 equals T1 times P2. P1 times T2, that would be this cross product here, equals P2 times T1, which would be this cross product here. Now you're solving for P2, so in order to do that, you have to get rid of T1. P2 is going to be P1, which is 0.40 atmospheres, times T2, which is 273 Kelvin, all over T1, which was 400 Kelvin. See the Kelvins cancel, leaving with a unit of atmospheres. And we should get about 0.273 atmospheres. Please make sure that you are independently putting these in the calculator to practice this and make sure you're getting this. Number 5, what is the temperature, a constant volume of gas starting at 400 Kelvin? So if we're starting at 400 Kelvin, that makes this T1. And you're apparently looking for T2. When you have pressure at 0.4 atmospheres, that would be P1, increases to 1 atmosphere, that would be P2. And you can see the volume is remaining constant. So we are looking for T2. You're given P1, T1, and P2. P1 is 0.4 atmospheres. T1 is 400 Kelvin. P2 is 1 atmosphere. Again, since the volume remains constant, volume gets canceled. And we are dealing with P1 over T1 equals P2 over T2. You cross multiply, get your cross products in there. And this becomes P1 times T2. And that's equal to the other cross product of P2 times T1. And again, it doesn't matter the order in which you write those. You're looking for T2, so to accomplish that, we need to divide away 1. All right, so let's put this in P2 is 1 atmosphere times T1, that's 400 Kelvin, over P1, which is 0.40 atmospheres. See, atmospheres cancels, your answer Kelvin. And you're going 1 times 400, which is 400, and you're taking 400 divided by 4. Yeah, 1,000 Kelvin. Number 6. If a truck tire holds 25 liters of air, so 25 liters is V1, at 25 degrees Celsius, that would be temperature. What will be the volume of air in the tire if the temperature increases to temperature 30 degrees? We'll call that T2. And the pressure remains constant this time. All right, we are looking for what will be the volume of air, V2. V2 is our question mark. We are given V1, we're given T1, and we are given T2. Now, V1 is 25 liters. T1 is 25 degrees Celsius. However, we need to convert this into Kelvin because the temperature should be in degrees Kelvin, not in Celsius. So we need to convert both of those. Recall that you do that by adding 273. So 25 plus 273 is 298 Kelvin. That's our initial temperature. And then we have 30 degrees Celsius plus 273. And that's 30 plus 273, that's going to equal to 303. Our equation again, V1 is V1 divided by T1 equals P2 times V2 divided by T2. And this time we are told that the pressure remains constant. So we're going to cancel P1 and P2 this time.
And you get volume 1 over temperature 1 equals volume 2 over temperature 2. Okay, rewrite the equation by taking cross products. V1 times T2 equals V2 times T1. You're solving for V2, so you need to divide away your T1. Cancels. And V2 is equal to V1, which is 25, not 25 degrees, 25 liters, times V1 times T2. T2 would be 303 Kelvin. And we're going to divide that by T1, which is 208 Kelvin. Take a second to put that in the calculator.
Francisco Chavez, please report to the main office. Francisco Chavez to the main office.
We're going to go 25 times 303 and divide that by 298. And the volume, so 25 times 303 is 7,575, divide that by 298. And the volume increased to 25.4. So it didn't go up very much, and that makes sense because the temperature didn't go down. Okay. But it's still a small volume increase to account for a small temperature. And finally, a balloon holds 20 liters of helium, we'll call that V1. At 10 degrees Celsius, we'll call that T1. If the temperature increases to 50 degrees Celsius, we'll call that T2. And the pressure does not change, what will be the new volume? T2 is our we are given V1, we are given T1, and we are given T2. V1 is 20 liters. T1 is going to be 10 degrees Celsius plus 273. Turn it into Kelvin, would be 283 Kelvin. Temperature 2 is going to be 50 plus 273. 50 plus 273 is 323 Kelvin. Write our main equation down. Again, the pressure does not change, so we get to exclude P1 and P2, and our equation is volume 1 over temperature 1, V1 over T1 equals V2 over T2. Cross products. And we have V1 times T2 equals V2 times T1. We're looking for V2, so again, you need to divide by T1. Plugging this in, you get V1, which is 20 liters, times T2, which is 323 Kelvin, all over T1, which is 283 Kelvin. See, Kelvin cancels. And you should also see you're dividing by a smaller temperature. If you divide your denominator smaller, your whole fraction will answer is bigger. So our volume should go up to 20. So 20 times 323 is 6,460. Divide that by 280. And it went up to, we'll just round that to 20, about 22.8. And I hope that you found this tutorial helpful. Please pause or rewind as necessary, and be sure to ask for help if you're still stuck.